Hey guys, so as promised, here's some more properties of logarithms that we're going to learn. So you learned the kind of simple one last time. You just learned to kind of rewrite that log function, or I keep doing that, sorry, log expression into an exponential expression instead, right? In this case, we're going to look at how to rewrite logarithms as logarithms, right? We're going to condense things, we're going to expand things, and we're going to make things simpler on ourselves. Okay, so these are some special properties of some log functions. Okay, so first, I'm going to stick with that color coding. Hopefully that works. So first things first, I have log base c of a plus log base c of b. Okay, so really the main thing you got to get here is that the bases are indeed the same. If the bases are the same, then we're in good shape. Then we can combine things. So what we can do is we can say, okay, log base c of a plus log base c of b, we can condense that into one log base c of a times b. So really we can combine those. We can say, okay, since they're the same base, even though they're separate, we can combine them. Okay, so we combine addition by multiplying, which kind of makes sense. Addition gets bigger, multiplication gets bigger, right? So associate those two accordingly, right? And then same thing over here. Really, this just means we can go backwards as well. So we have log base c of a times b, and we can separate them, we can expand them into log base c of a plus log base c of b. Right, so that's just backwards and forwards for you. But again, adding, multiplication are both getting bigger, right? They're both things that you do to increase things, so that it would make sense for them to go hand in hand, right? When I add two logs together, if they have the same base, I can combine them and multiply whatever's inside. And then kind of similarly, just, opposite, vice versa, is going to be log base, let me zoom in a little bit, log base c of a, and then minus log base c of b. How can I rewrite that? Well, this time we're subtracting, so you guessed it, right? It's probably going to be division. So I'm going to take log, again, those bases have to be the same, which is base c, and I'm going to take a over b. So subtraction is going to imply division. Both things get smaller, right? Which makes perfect sense. Well, they should go hand in hand. And then again, just going backwards just to make sure we understand it, if I have log base c of a divided by b, I can separate those, I can expand those by saying, okay, well, if I have the log base c of a, I can subtract the log base c of b. Okay, so hopefully those make sense, right? Addition goes with multiplication, subtraction goes with division. It only makes sense, right? And then this last one here, going to be a little bit different. Hopefully this makes sense though. Really and truly, the only way to do this is to say, okay, log base c again, and we have an a, but it's being raised to the x power. What's going to happen to that power? We can actually bring that out front. That exponent we can bring out front. So let's see what that's going to look like. I can bring that x out front, which is pink. So here's the x times log base c of a. So that c and a aren't going to do anything, but I can take that exponent that a is being raised to, and I can switch it out to the front. I can grab it, throw it out front, right? And that's going to help us look at things in a different way. So then, conversely, right, I can do the same thing going backwards. I can take x times log base c of a, and I can bring that up to as an exponent. I can do it the other direction as well. So that will simplify down to being log base c of a to the x. Okay, so these are our three properties. Now, addition goes with multiplication, easy. Subtraction goes with division, easy. They go the opposite way as well, easy. This one's the only one that can be a little bit different, but just think of it as like grabbing it, throwing it to the front, or taking this thing in the front, throwing it on top, right? Don't think too far into that. Don't try to understand that too much. Just kind of understand what's going on there, okay? So let's go ahead and apply these and see if we can get this going. So it tells us to condense the following logarithmic expressions. So condense them, meaning combine them, put them together. So again, I have log, and I'm going to zoom in here. I have log base 2 to the of 5 plus log base 2 of 7. And I'm going to combine these. So basically I'm going to say, well, that's going to be equal to the log base 2 of 5 times 7. I'm going to make that multiplication sign bigger. And then I'm just going to write it completely different. So I'm going to just say, okay, well, that combined is just the log base 2. 5 times 7 is 35. And there you go. Simple as that. Right? Simple as that. Remember, multiplication implies, addition implies multiplication. Right? Pretty simple. Now, let's move on down to number 2, log base 8 of 21 minus log base 8 of 3, right? So that's just going to imply, again, just combine them, just nothing big, right? So I'm just going to combine log base 8, and now I have 21 over this 3. Right? So, again, I'm just going to write this in a nice little color here. So I have log base 8, 21 divided by 3 is 7. That's my answer. Pretty simple. Pretty simple. Okay. So, moving down to number 3. Let's see if we can remember this one here. So I have 4 times log base 10 of x. Right? So let's rewrite this. Remember, really all I'm doing is grabbing this guy and throwing it to the top. So really all I have here is log base 10 of x to the 4th power. And that's already simplified, but I'm going to rewrite it here in this other color. Just so we're on the same page here. Right? Log base 10 of x to the 4th. Very nice. Very nice. Right, now let's try one that has a couple of steps, not just one step. So let's try number 4 here. Just take this one step at a time, guys. No big deal. Right? So let's just take this very first part here. Let's take this, and then we'll combine here in a second. Okay, so first things first, I've got this 3 out front being multiplied by log base 6 of x. So let's rewrite that. Okay, so what I have here is log base 6 of x to the 3rd. Now I'm going to bring this down and say, okay, well, really what I'm doing is adding that to the log base 6 of 8. Right, so now I've got some good stuff, right? I've got base 6's here, and then I'm adding. So since I'm adding the same base, I can multiply. Let's use purple for this, or pink for that, and then let's use the red over here. So really all I'm doing is combining. So I'm just going to grab this and say, okay, this is the same thing as log base 6 of 8x to the 3rd power. And there you go. Right, so even if there's multiple steps there, no big deal. Take it one step at a time, combine them, and x to the 3rd times 8. Yes, you could have written it like that, x times, oh, sorry. You could have written it as x to the third times 8. Yes, but no one writes it like that, right? That usually goes right up front. Okay, so let's move on to expanding now. Let's expand things. Instead of combining things and making it look simpler, let's expand things. This is actually going to be really beneficial later on when you start doing this to solve equations and stuff like that. This is really beneficial to be able to expand things whenever you need to. Okay, so we have a log base 7, and what are we multiplying together here? Well, we got a 5, and we've got an x. So let's expand those. So first things first, I've got log base 7 of the first thing I'm multiplying, which is 5. And remember, multiplication, getting bigger, what do you think of? Addition or subtraction when you get bigger? I think of addition. So we're going to add log, and remember, it's got to be the same base, so log base 7 of whatever we're multiplying by. That's x in this case. And there you go. That's it. So again, I'll write this all in one color just so we can see it. So log base 7 of 5 plus log base 7 of x. And there you go. Right, again, it's the same process. You're just going backwards now. No big deal. So now let's go down to number 6. I see division in there, which means hopefully some alarms are going off in your head that we're going to be subtracting. Right, so let's just go on. So log base 3 of, we're taking a 7 and we're dividing it by an x to the 4th. No big deal. Let's go ahead with it. So I've got log base 3, remember they've got to be the same base, of 7 minus log, again, base 3 of x to the 4th. But I'm not done here, right? I'm not done there. I've got to grab this 4, boot it to the front. So really, I'm going to write this in that same color. I have log base 3 of 7 minus, and I've got to put that 4 out front, log base 3 of x. Right. Easy peasy. Okay, easy peasy. So that kind of concludes that. If you can expand them and you can condense them like we've done in those first 6, you're going to be just fine. Right, and then one more quick thing at the end here. This is called the change of base formula. So change, actually let me write it in a different color here. Let's do red. So this is the change of base formula, right? So this is actually really important as well. I talked about it already, like when you're solving equations later on in your math careers. These are really beneficial. This change of base formula is really beneficial as well. So this is a pretty simple concept. Really, so back in the day, I know now calculators are really advanced and you can put log base anything, right? But back when I was in school, right, and people even before me, it wasn't that easy, right? You couldn't just put log base 6 of this, right? You couldn't put log base 6 of 10 equals what? You just couldn't, right? Log was always base 10. Log, if you were just to see log of 6 and you put that in a calculator, it automatically says, okay, let's take that and put log base 10. That's your default log base 10, okay? But there are times when you don't have log base 10. For example, every single problem we've done so far, right? So you got to be able to put those into a calculator. Obviously, like I said, now you don't really have to, but this log base change is really beneficial in solving equations later on as well. So honestly, what all you do is you take log of this first number. So how am I going to write this? This is going to be weird. So log of that first number, log of b, and you're going to put it over log of a. So that's going to look like this. I'm going to actually erase that because that looks just horrible. And I'm going to say, okay, log of b, and a is your base. So what you're going to do is take the log of b over log of a. And what I'm going to do here is separate that change of base. Okay, so log base a of b is the same thing as saying log base 10 of b over log base 10 of a. Remember, the default when you don't see a base is 10. So log base a of b is the same thing as saying log of b over log of a. And then same thing going backwards, right? I know we've done this plenty of times and you're already tired of it, but it's really the same thing going backwards. So if I take log of b and I put it over log of a, I can rewrite that and say that's the same thing as saying log base a of b. Same thing, same thing. So we're just going to practice one of those because it's extremely repetitive. Once you see it, you get it, and it's simple as that, right? So I've got log of base 8 of 9. So remember, that big number, the number that you're taking the log of, b, right? We have b up here. Whatever that big number is, it goes on top. And then the one on bottom goes on bottom, right? Simple logic. So let's write that out. So we've got log of 9 over, I forgot to put this, log of 8. Simple as that, right? Same thing, same thing. And if you put that in the calculator, right, log of 9 over log of 8, you are going to get 1.06. So again, it is very handy for when you're solving things, but back in the day, right, you could not just put this one in a calculator. You could not just put log base 8 of 9 in a calculator. If you want to know that value, you'd have to use this change of base formula in order to get it. Okay, so that concludes. Hope you've enjoyed these videos. Yeah, so let your teachers know if you have any questions. Let us know, email, anything like that. We're happy to help. Okay, have a good one.